Hello again, everybody. In today's video on probability, we're going to be looking at independent and dependent events. Now, the difference between the two can be summarized like this. Would you consider yourself to be an independent person or a dependent person? Well, if you're independent, that means you're not affected by anyone else's choices or really anything. Like you make all your own decisions. However, if you're dependent, that means you are affected by other people in your life or other events in your life. Now, for most of us, we're a combination of the two. But in probability, it often is one or the other. So the thing you need to remember as we go through each of these examples here, does my first choice or does what happened initially affect my second choice or my second pick along the way, whatever the question is. So let's have a look at three examples. So we've all taken multiple choice quizzes before. Well, this particular one has 6 questions. Now, for each question, there are 5 different answer choices, maybe like A, B, C, D, and E. So if a student guessed on each of the questions, what's the probability of getting all 6 questions correct? So you know the deal. You wake up in the morning, you go to school, it's history, and it's a 6 question quiz. And you realize you forgot to study, so therefore you have to guess on everything. All right, so how do we figure this out? Well, I'm trying to figure out the probability that I get 6 correct answers. So let's have a look at the very first question. So we'll say that's question 1. And we ask ourselves, what is the probability that I'm going to get that question right? Well, I got 1 chance out of 5 possibilities. So therefore, my probability of getting it correct is 1 out of 5. But then I have to go on to the second question. Now, does my answer on the first question affect my answer on the second question? If I'm just guessing, then it really doesn't. So on the second question, I still have a probability of 1 out of 5. So these two events are what we call independent, because my first choice for question 1 doesn't affect my choice for question 2. Now let's look at all the other 3 questions. Other 3? Apparently I can't count. The other 4 questions. All right, because we have a total of 6. I need to go back and learn math again. So the probability of getting question number 3 right is still 1 out of 5. Getting question 4 right, again, is 1 out of 5 because it's not affected by any of the choices that went before it, and so on for question 5 and question 6. Now, to find the total probability that you're going to get all 6 right, remember, you have to get this one, followed by that one, followed by that one, and so on. And in mathematics, when you're following something like that, when it's something and then this, we multiply the probabilities. So, what's my answer going to be? Well, there's a couple of different ways of writing it out. 1 over 5, 6 different times, would be the same as 1 over 5, all to the power 6. So you're probably going to need a calculator for this. Now, you could also use decimals as well. 1 divided by 5 is 0.2, also to the power 6. So what I'll do is I'll get my calculator first, which apparently I forgot. So here we go. Calculator, boom, there we go. All right, so let's do 1 divided by 5 first. So 1 to the power 6 is just 1. 5 to the power 6 will give me 15,625. So that means you've got a 1 out of 15,625 chance of getting all 6 questions right. It's pretty low probability. I mean, yes, it could happen. Is it likely? No. Could it happen? Yes. You could also do the same thing as a decimal, 0.2 to the power 6, and that would give you this scientific notation here. So that just basically means that you move the decimal place 5 times to the left. So 0.1234, and then on the fifth one, 64. So again, you've got your answer as a fraction and your answer as a decimal. Either one is really totally acceptable. You just need to know how to work back and forth from each of them. But again, the principle is the same. Because this is independence in play, the first choice doesn't affect the second choice didn't affect the third choice, and so on. So that's an independent probability question. So now let's have a look at a dependent probability. Let's imagine you have that same morning. All right, you have a history test in the morning, you're rushing to get up, and you reach into your sock drawer. Now, in your sock drawer, apparently you have 4 red socks and 6 green socks. You're stylish. What's the probability that you reach in and pick 2 red socks? Now, remember, after you pick the first sock, you're not going to replace it. I mean, how dumb would that be? You take out a sock, and then you don't put it on, and then you put it back, and then you take out one more sock, and you only wear one sock. Now, I know you're probably thinking to yourself, why would I just randomly reach into a sock drawer blindly and pull out 2 socks? I mean, you have eyes. Well, let's just pretend that it's complete dark at the moment and you can't see a thing. So, how do we figure this out? Well, we want to find the probability that I get a red sock followed by a green sock. Yes, that's how I write my G's. They're kind of funny. All right, so let's start with the first choice. All right, you reach in and you pick. I'm sorry, you're not picking a red one and a green one. You're picking 2 red ones. All right, there we go. Because yes, why would you not want them to match? All right, well, no, that's the style these days. My daughter wears two different types of socks. I'll never understand it. All right, so again, we're trying to figure out the probability of picking 2 red socks. That means we want to pick a red one followed by a red one. All right, well, we've got 10 socks in total. And what's the likelihood that we'll get a red one? Well, 4 out of 10, because there's 4 red socks out of a total of 10 socks. But now that's going to be followed by, so remember, we're going to multiply the probability of picking another red sock. Now remember, you've already picked a red sock, so that means there's only 3 red socks remaining. And you've already picked a sock, so there's not 10 socks remaining anymore. There are a total of 9 socks altogether. So therefore, this is a dependent probability because my second choice is affected by my first choice. So I've got 4 out of 10 multiplied by 3 out of 9. So what you need to do is you need to multiply these 2 fractions together and then simplify. So there's 2 ways of doing that. You could just multiply straight across, get 12 out of 90, which is great. What I like to do is I like to simplify as I go. So 4 out of 10 will reduce to 2 out of 5. 3 out of 9 will reduce to 1 out of 3. Nothing else will simplify. So 2 multiplied by 1 is 2. 5 multiplied by 3 is 15. So your answer as a fraction will be 2 out of 15. So not a likely chance that you're going to get 2 red socks. So there you go, 2 out of 15. All right, now this next question, I kind of like it because maybe you're not partial to red socks or green socks. Maybe you just don't care. Maybe you just want a matching pair of socks. So again, there are 10 socks in the drawer, 4 red, 6 green. What's the probability you reach in and you pick 2 socks that are the same color? Well, you got to look at all the different possibilities here. So essentially, you want to try and find the probability that you pick a red sock and then a red sock. All right, those will be the same color. But then you could also pick a green sock followed by a green sock. Those would also be the same color. Now we know from before, from this question up here, that the probability of picking a red sock is 2 out of 15. Now what's the probability of picking 2 green socks? Well, probability of picking the first green sock, there are 6 possibilities out of 10. But remember, once you pick that green sock, you've only got 5 green socks left out of a total of 9 socks altogether. So let's go ahead and simplify. So 2's will go into each of these. 2's will go into that 3 times. 2's will go into that 5 times. Now this won't simplify, but I can do 5 over 5 right there. So 1 and 1. And then the 3 and the 9 here. 3's goes into 3 once and into 9 3 times. So multiplying across, you're going to get 1 times 1, which is 1, and then 1 times 3, which is 3. So you've actually got a 1/3 chance of getting 2 green socks. So that makes sense. It's more likely that you're going to get green socks together than you are red. Well, you got more green socks. Now, the question though was, what's the probability that you get the 2 socks being the same color? Yes, there's the bell. It's the end of the lesson, so I'm going to finish this up. So it's an OR question. So to find the probability of getting 2 and having them the same is basically 2 out of 15, and then you're going to add that to 1/3. So I'm just going to wrap this up because I think students are going to come in any second. So that'll be the same as 2/15 plus, that'll be 5/15. When you add that together, you'll get a total of 7/15. So there's the probability that you'll get two socks exactly the same color. All right, thanks very much for your time, everybody. And if you need any extra help, again, just reach out to Miss Lynch or Miss Wiltsey. Don't reach out to me. Okay, all right. Hey, we've got to announce what's going on as well. All right, bye, everybody. Have a great day.
Please stop by the counseling office at this time. Billy